Hi, everybody. Welcome, and thank you all for coming to the Tcl conference this year. I really appreciate it, and speaking for Cliff and Andreas and everybody else who put this together, thank you. My name is Karl Lehenbauer. I am the co-founder and chief technology officer of FlightAware, and I'm talking today about Sequelbird, which is a tool that we wrote to keep our to cache Postgres tables locally into SQLite. So FlightAware is a pretty big Postgres shop. We have a Postgres database server that hosts hundreds of tables with row counts from 1 to hundreds of millions of rows, and we run about 10 read-only replicas that queries that don't do write can be load balanced to.
Short interruption. Is it okay that it's blank?
Yeah, I want that blank right now.
Okay.
I'm kind of following Tufty, that academic who rants about speaking, so I'm not just putting my bullet points up here. So I'm only going to have slides up here when I have something to show. Okay, so the machines, these database servers, they're pretty good size, by our standards anyway. 28 64-bit Xeon CPUs, 512 gigs of RAM, and high-performance SSDs for storage. But all SQL that can cause writes has to be executed on the master server. We also vet queries before allowing them to be run on the slaves. We have to, on the replicas, we have to make sure that the latency in bringing the replicas in sync doesn't skew query results or cause malfunctions for users. So we pay close attention to the master's load and its performance, because it is a potential performance bottleneck that can't be substantially improved through greater multi-machine parallelization. Okay, so there are some multi-master extensions for Postgres, and there are multi-master database servers, but in our experience so far, they are either immature or slow or both, so they don't help. In response to performance concerns about the load on the primary server back in 2012, we began developing a caching system based on speedtables that we called Superbird. Eventually, on startup, Superbird could allocate a bunch of shared memory. It could replicate tables from Postgres and make it available to clients on the machine that could attach the shared memory and access it directly through memory. It was pretty cool. Tcl code did most of the work, but the importing of Postgres results into speedtables was done directly in C, so that Tcl didn't have to look at every row of data being returned, because that would have been super slow. So here's an example of what a query, Sequelbird query looked like, a Superbird query. I don't know if you can see this, I'll just make this short. So it's basically key value pairs. So we say we want to search a table called boards. We want to find a value, field of reg that has this value of this variable ident. Here's the fields that we want out of the table. We want it sorted by departure time. We want the results pulled into a Tcl array, and then we have a code body that executes for each row returned. So queries had to be written in the speedtables query language, like I just showed you. But one cool thing was that if a table wasn't replicated in the shared memory, then the code could fall back. It could translate the request from that query language to SQL, and it could perform that using Postgres. So machines didn't have to replicate all of the tables in order to still use this query language and access tables. So we liked that a lot. That helped out a lot. This worked out pretty well, and we made use of it, but it had several drawbacks. It loaded all the replicated tables into memory, and so typically we would allocate at least 24 gigabytes of memory for these replicated tables. A single process handled all the replicating of data from Postgres, and with the tables that we were replicating, and some of them fairly large, it would take on the order of 20 minutes for the program to start up. Likewise, when shutting down the program, and this was really annoying, the operating system would pointlessly flush all the shared memory to disk. So 24 gigabytes of shared memory would get written out to disk. And the thing that really was annoying about that was, as soon as it was done, we would delete that shared memory disk file and create a new one anyway. So it took 20 minutes to start up and 10 minutes to shut down. So anytime we were confronting reloading Superbird, slightly changing the software or whatever, every single server that ran it, the poor guys in ops had to go through these process of these more than 30-minute restart cycles. So we hated that. Speedtables, though very fast, has a limited and unique to itself query language, like you just saw. And among many limitations that it has, a big one is it doesn't support joins. So we did over time bring Superbird into production and into a pretty high state of reliability. It is robust at reconnecting to the database. It'll retry many times over possibly a long period of time should it lose its connection. That's so it doesn't have to be like restarted or it doesn't malfunction and quit or whatever. When it takes 30 minutes for a program to restart, you work pretty hard. It's important that the program be reliable even when there may be intermittent problems like problems connecting to the database or problems getting results. So we consider it to be a win and an important part of our arsenal, but we weren't completely satisfied for all those reasons I just gave you. So in mid-2017, last year, we started looking at whether it might be possible to do the same thing, only to use SQLite as the cache instead of speedtables. So since SQLite is storage-based, or can be storage-based, a restart of the replicator wouldn't require everything to be re-replicated from scratch. That was highly attractive. SQLite supports several different journaling modes in order to provide transactions. And there's one called wall mode, or write-ahead logging mode. And that one in particular is significantly faster than journal mode, which was the original thing it had. In wall mode, it allows unlimited concurrent readers and one concurrent writer. And that was just fine for us because we'd have this one program that would be writing and have many programs that would be reading. And wall mode also is faster and it does fewer f-syncs, so it's easier on the storage. That seemed like it would work for us, and the single writer limitation, like I said, isn't a problem for our purpose. So since SQLite, as I call it, is SQL, there was the distant possibility of being able to run the same SQL queries in SQLite that we were running in Postgres. That was kind of tantalizing. Okay, this is what we call Sequelbird. So the first step was to read the table and index definitions out of Postgres. So the SQL standard has a thing called information schema, and Postgres has this, and I think MySQL has it, and I know Oracle has it, and it's a standard way to query these tables and find out about the schema, find out table definitions and columns and what their data types are, and what their default values are and things like that, find out all the indexes. However, the information schema doesn't support like certain things like in Postgres that are unique to Postgres. And we already had all this code to dig schema out of Postgres. So we just decided we'd go ahead and be specific to Postgres. So we get the schema definitions out of Postgres directly. Interestingly, if you're a Postgres user, there's a command called PSQL, that you use to run and interact with the server directly, and you can do creates and selects and things like that. And so there's a command line switch to pSQL called --echo-hidden, and when you run pSQL-echo/hidden and then you say, okay, well give me the definition of this table, it'll give you the definition of the table, but it will show you all the SQL that it executed to find the definition. So it's a real good way to get insight into the relationship between the system tables and the tables that they define. Okay, so without much work, we were obtaining the table definitions. Furthermore, we understood them, which is to say, we didn't just have the table definition. We actually had, here are the columns, here are the attributes of the columns. Like we weren't having to parse the definition. We knew from Postgres what the columns were and what they did. So next we begin to examine how we would support the Postgres data types between Postgres and SQLite. So at first it looked a little scary. Postgres has a rich set of data types, dozens of data types natively, and it has user-defined data types, whereas SQLite has only 4 data types. It has integer, real, text, and blob. And so, blob's kind of a special case, so you might say it has 3 data types. Could the Postgres types, or at least the ones we used, which are a lot of them, but maybe not the more exotic ones, could they be translated and meaningfully be used with SQLite's limited types? So the answer was yes. Postgres' many integer data types can be mapped to SQLite's single integer type, which also scales from 1 byte to 8, so it can hold like up to or almost up to 64-bit integer values. And it can store big integers, right? Real and double precision can be mapped to SQLite's real type, and Booleans to integers, and I'll say more on that in just a minute. Almost all the other types, varchars, timestamps, intervals, dates, internet addresses, etc., we would just map those to text. Soon we had code reading SQL definitions from Postgres, creating new ones for SQLite, and we were running them. We could also create indexes. So this was sort of interesting. A small number of Postgres indexes use features that are too fancy for SQLite, so when we try to execute the create index, it fails on SQLite. And so what we do in that case is we just skip that index, log a message reporting the problem, and move on. You would want to look keenly at those to make sure that some index that didn't get created was not causing a severe performance penalty on your SQLite queries, but we also provide a way to index additional columns, and in fact, in general, we're kind of over-indexed because we're pulling a table from SQLite that may have a ton of indexes for all sorts of different uses, and then we're only using it in a narrow way, but we're still maintaining tons of indexes on like email addresses and all these different columns like on the user table and stuff like that. So the idea was initially we'll select all the rows from the table, we'll suck them into SQLite, and then we'll use a trigger maintained column to know when the rows have changed in Postgres, and so then we'll be able to do queries just saying, give me everything that's changed since the last time I looked. And this is the SQL function to keep a changed column updated. So we define a function and we say, okay, set the new change time to the current timestamp, and then we define that trigger on our table, and we've done that work of putting that into all the tables that we are intent on replicating. So we had something working fairly quickly. You can make a list of tables that you wanted replicated and how frequently they should be refreshed. You could tell that into the console port of the program, and you could manually refresh tables, start replicating new tables, drop tables, and so forth. It seemed pretty cool. But there was still no concurrency because there was still a single program updating all the tables, and some tables needed to be accessed with different credentials from others, and the whole list of tables thing was too flat. So that's to say, like, one application needs these 10 tables replicated, but another application on the same machine needs these other 10 tables replicated. So now in this one file, we're defining 20 tables to be replicated, and you can see that just that was going to cause a lot of problems, right? So we were able to solve both problems by creating what we call replication sets. So a replication set is a higher level of specification that names one or more tables, and each replication set is stored in its own SQLite database file and will have its own program to replicate the data from the database to it. Okay, this is the definition of a replication set. It's just a proc that ends up writing some tables in SQLite that we use to keep track of what we're doing. So here, just quickly, is we say, okay, I want to define a replication set called web. The schema, which is the name, which is a name when you attach the thing in SQLite, is going to be called web. Console port 1282 is going to let me tell that into port 1282 from the local machine and interact with the Tcl interpreter directly. DB file says the name of the SQLite database file, and then here's some key stuff. This is the list of tables that I want to replicate and how often. So like every 10 seconds, we're going to refresh these frequently refreshed tables. Every 5 minutes, we'll do the airlines and we'll do the METARs and TAFs, which are weather forecasts. And every 4 hours, we'll refresh the aircraft table and the list of items and the stuff from the FAA and the stuff we know about all the airports and the stuff we know about all the aircraft that are registered. Okay, but that just gets translated into insert statements that go into the database. It's kind of cool. All right. So Each database file has its own replicator. We call that Babybird. And there's a manager daemon called Sequelbird D, or Sequelbird daemon. It starts the Babybirds. And there's a Babybird for each replication set, and then those process concurrently, inherently, because each program stands alone. So now we can load, if we're loading 40 tables, we might have 7 programs loading those 40 tables. So a particularly slow to load table, because it has millions of rows and a ton of indexes, will be put in its own replication set. And so we've gotten our startup time from scratch down to about 5 minutes, because one of those tables is really big and has a ton of indexes, and it takes that long. When attaching multiple SQLite databases as different schemas, SQLite will find tables in whatever schema they're in. This is really cool, without requiring the schema to be explicitly referenced, which is ideal as long as there are no instances of the same table name in multiple schema. With this approach, there's no cognitive penalty on developers to explicitly have to call out which replication set they're accessing a table in. And furthermore, there's no likelihood of breaking code because a table is moved from one replication set to another for operational reasons. So like if we had to call them all out and then we move the replication set, we'd have to go find all the code and then reference the other schema. So Sequelbird runs the Babybirds. It collects and logs their output. It looks for a particular message from each Babybird that says, I'm up to date. So if a Babybird starts and there's no data, it starts and it fetches all the tables and it creates all the indexes. If it starts and the thing is there, it just refreshes and looks to see what happens. And when it's got everything, it writes this message out to its output saying, I'm up to date. And so Sequelbird D, let's say it starts 7 Babybirds, and so it's watching for 7 I'm up to date messages. So like once the last Babybird child is up to date, then the Sequelbird D program will background itself. And so this is really important for startups. So like we have 300 Apache servers that are going to access Sequelbird and provide the FlightAware website to people. But Sequelbird isn't there because it failed to start or whatever. So the point is Sequelbird won't return until it's ready to go. So then we don't bring up Apache before Sequelbird is ready, or before Sequelbird is there, or whatever. Okay, so although we were able to map Booleans to integers, a fair bit of our SQL failed. So we're trying to execute our PostgreSQL code on SQLite. And so we try this and it works, and we try this and it works, and we try this thing and it doesn't work. And the reason it doesn't work is because SQLite doesn't recognize the operators for, I don't know if they're operators, the true, is false, is not true, and is not false. So I reached out to Richard Hipp. A lot of you guys know him. He couldn't be here this year. He's super sad about that, but he's in China on business. Super long book thing. I told him we would move the conference for him, and he said no, he couldn't do it. But anyway, I reached out to him and explained the issue we were having, and he graciously added support for that, for the expressions is true, is false, is not true, and is not false. And not only did he do it, but he did it super quickly. Like within days, it was in beta. And I got this email from him, okay, we did it. And of course, this is covered by our 100% code coverage, and it's completely implemented. And that was really great. He had also previously added support for the without nulls option when you're doing queries. This is something that we created for PGTcl, and we use it a fair bit. And it's where, so we're doing a select and we're getting rows from the database into our array. Typically, nulls, null values are created with a null value string, which is usually the empty string. So we get this column and it's empty, and then we don't know if it's null or if it's just an empty string. So with the without nulls option, when it's retrieving a row and setting it into the array, it says, hey, this value is null, and it actually unsets it from the array. So we have to use the info command to see if the value is there, and this gives us true out-of-band detection of nulls as distinct from empty strings, which I think is very powerful. So the point is that PGTcl has that, and then now SQLite has that. Okay, we also modified PGTcl. libpq is the name of the C library that you can use to talk to Postgres from a C program, and that's how Tcl talks to Postgres, is with a Tcl extension called PGTcl that is written in C that talks to the libpq library. So normally when you do a select, all the results are buffered by libpq, and only when all the results have been received does libpq start performing the code that you asked it to do on the results, or hand you the results. This is normally probably good, and I can give you the details later if you're super interested in knowing that. But when you're getting back millions of rows, it kind of sucks, right? Because you get back like 10 million rows, your program grows by whatever that memory amount is, and only once they finally completely come back can your program start to do the work of importing the value from those rows and storing them in SQLite. So they added, the Postgres team added to libpq a option called row by row. And so in row by row mode, you get incremental returns of results. So you get called back, here's some results, here's some results, here's some results, until they're all back. And so you can do work while the results are streaming in. So Peter De Silva extended PGTickle to support that, and we use that. So Babybird, as it's receiving the results from this big query, can be doing the work of creating it in SQLite, and that made it faster to start up. Okay, one more thing that we really, so this is kind of interesting. There's a feature in SQLite where you do queries, and you can specify variables. You can say colon variable name, or you can say dollar variable name, and it will recognize and kind of substitute in the Postgres variables. And Richard said, we were talking about PGTickle, and he was like, you should implement that. And I was like, no, I don't want to implement that because I have to tokenize the SQL, and I think the overhead will be too high, so no. That was like 2 years ago, I think I said that. And then I used SQLite a lot, and I was like, man, that is a really, really, really cool feature, because then the SQL becomes like a static string, so it can be compiled, and then the variables get bound into those strings, and it's really powerful. So Peter added the -variables option to PGTickle's PGSelect and a couple routines that are like that, which provides the same variable referencing behavior that SQLite has. So you might see here, we're kind of pulling SQLite and we're pulling Postgres closer together. So we started using Sequelbird in various places in our infrastructure, and it's working out pretty well. But there was a sort of tantalizing idea, and I kind of touched on it, that as with Superbird, it might be possible to take a select statement, try it in SQLite, and if it doesn't work, because maybe some table isn't replicated or it's too complicated or whatever, that we can actually fall back to Postgres behind the program's back, perform the same query, and give the process the results, and the process would never know that the results came from Postgres instead of from SQLite. Changes to SQLite and to PGTickle, the vast majority of our SQL queries, including large, surprisingly large and complicated ones that work in Postgres, will run unmodified on SQLite. That's really the grail for us. And we succeeded. Sequelbird's apex user function, called Sequelbird Select, will try the SQL query first in SQLite and fall back to Postgres if it doesn't work. And here's an example of the Sequelbird statement from our actual code base. So we say Sequelbird Select, here's the code, sorry, and there's a bug in it because the array is called I, and I tried to p-array row, so that will actually fail. But if this was I or that was row, it would be fine. The select statement did come from the actual code. You can see it's got coalesce in there, it's got a left join. This works. We have at least 75 places in the website, code that's about to go out that switches all to Sequelbird. So we're pretty excited about that. Now, this thing about it falling back and being able to do Postgres or do Sequelbird, this is a capability that you can do with Tcl that you can't do with almost any other language. You can't do it with Java or Scala or Swift or Python or Perl, and I think that's pretty cool. It has to do some kind of precise use of upvar and uplevel and catch, but it actually can work, right? Like akin sitting there being called by this thing that expects this code body to run, I've intercepted that, and I can cause a different code body to run, but it's at the right depth on the stack, and it's at the right, it's referencing the right variables in the stack frame of the process that calls it, and that's a really, really, really cool thing about Tcl, like I said, that almost no other language can do. So the current status of Sequelbird is that it works and it's running on at least 60 of our servers. We have replaced Superbird with Sequelbird successfully in some large subsystems, and we're in the process of the biggie, which is replacing it on the website. That work has been done, it's in test, and pretty soon it'll be in production. John Cohn, who's here from FlightAware, has done much of that work. John also extended Sequelbird to support replicating views from Postgres, which was a great insight and is a really nice feature. Okay, so we're willing to release this as open source. We think it would be useful to a lot of people, and it would be something where even in a non-Tcl shop, they would install Tcl to get this sort of capability. The only problem is that it's got some FlightAware-isms in it that need to be removed, particularly around configuration and around monitoring. We would like to remove it in a way where it would be pluggable or something, because we don't want to maintain two code bases. So if we open source it, we want to be able to use the open source code base and still get our FlightAware-isms. So I think we'll be talking about that some maybe this week after hours. There's a command line tool called Sequelbird, and what it does is it goes and it finds all the Sequelbird databases, the SQLite databases, and it runs the SQLite 3 command line interface program, and it gives the command line arguments to attach all those database files. So maybe there's 40 tables and there's 7 database files, but if I just say Sequelbird and I get a prompt, I have all those attached and mounted, and I can do all the commands. That's really nice too. So we used to have to sort of telnet into the program to examine the shared memory and talk to it like that, but now completely externally from the program, I can start up SQLite, I can poke around and do selects and counts, and hopefully not updates, but you can, just maybe not a good idea. Okay, Peter De Silva has also written a program called, or a tool called PGdeltaflood, which is a program that follows the Postgres write-ahead log and can update SQLite from that. We haven't plugged it all together yet, but I think it's really promising. It holds the promise of keeping the SQLite replicas much more up to date, because it would just see the updates going across from the master to the replicas and pulling those out and issuing them to SQLite. And it would be less overhead, because the Sequelbird program wouldn't be generating these queries saying, give me everything that's changed, give me everything that's changed, like it does now. All right, and that's it. Questions?
Carl?
Yes.
In an F3201 proliferation of frameworks, what does TDBC need to do better for you to use it?
What does what?
TDBC.
What does TDBC need to do to use it?
Yeah.
And I haven't even considered trying.
Because a lot of what you were describing, the database introspection, the homogeneous interface between different databases, and as well as Postgres and SQLite, TDBC does MySQL MariaDB, and it does ODBC, which gives you DB2 and Oracle and SQL Server.
Really? So you think it has sufficient introspection to?
It has the table view and query introspection, FAR key introspection, all of that good
Cool.
stuff, so you can make network queries. And I recognize that the SQLite interface will be too slow for you to use because
Directly?
Because it's got Tcl code in line.
A lot of indirection.
All the others are in C code. And it's one of the reasons I was grabbing my pen was that I was noting that you managed to convince Richard to give you distinction between null and any string value, which was something I had never quite managed to convince him was needed.
But it's not in the database tables itself. It's just in the query interface.
That's where it's needed. That in Tcl everything is a string. Null is not any string.
Right. Yeah, that's cool. I don't know. We'll look at that. I got a quick, go
Because, I
ahead.
mean, that now ships with Tcl'. Since SQLite 6
Oh, yeah.
ships with
Yeah.
Tcl'.
Yeah, no, we'll look into that.
Obviously, there's work needed to be done, but I was just a little surprised you hadn't looked at that.
Well, we've been on Postgres for a long time, like since the mid '90s, kind of in two predecessor companies. So it was never a big impetus. We never had a big impetus to try to use MySQL for any of this.
Yeah, but I mean, once you start going multi-database,
I get it. That could be really cool. A quick side note about a Richard thing. So he's real proud of the 100% code coverage. But if in version 3.23 or 3.24, if you do a package require SQLite 3 and you do SQLite 3 enter with no arguments, it's a segmentation violation. So you're like, dude, I think you missed that part for your 100% code coverage.
I thought the Tcl' API was not something that was in his...
It may not be.
test coverage.
Probably not. All right.
One thing to Kevin, TDBC, you asked what it would need, what feature it might need, and probably the big feature is incremental access to query results. I don't think it has that right now.
Yes, sir.
API provides.
Didn't you run into a situation where the entire query had to complete?
Yeah, for SQLite.
That's just for SQLite.
As far as
Just the
I know.
SQLite.
Right.
Oh, okay.
And SQLite, yeah, that's a known problem because I was having to deal with the existing SQLite template.
All right. Any other questions?
Good to see API.
Comments, complaints, concerns? Nathan?
The behind the scenes query fulfillment by PostgreSQL. You were talking about implementing that via upvar and uplevel or
And catch. Yeah.
Could it have been implemented by renaming the command?
Well, okay, so the question is, could the thing where it transparently tries Postgres or SQLite have been done by just renaming the command? And the answer, I think, is no, because it doesn't know until it tries the command with SQLite that it can't do it. It does keep a cache of failures, so if you're generating the same string, it won't try the query over and over again. But since it tries it first with SQLite, just renaming it won't do it. Yeah. We also did this in Superbird, and we've done it in some other things. There were some good examples in the man pages of Tcl'.
Although you can use renaming the command as a way of maintaining the cache reference.
Of what?
Maintaining the cache. So the second time you do it, you get the other. You get results.
Yeah, but the command is getting executed for all the different queries. The caches of the SQL string itself. It says, I know this didn't work last time, I see it again, so I'm going to just go straight to Postgres.
I'm thinking too much from the TDBC perspective, where a prepared statement is a command.
Yeah, okay. And SQLite prepares statements behind your back, but they're not commands. So, all right, any other questions? Okay, thanks everyone.